In the 1920s, an American astronomer named Edwin Hubble identified that light coming from distant galaxies was red-shifted. So the astronomer was Edwin Hubble, and his discovery was that light from distant galaxies was red-shifted. So I'm going to explain what that actually means, what redshift means, and what that actually tells us about the universe. So to firstly understand redshift, we need to understand the Doppler effect. Now the Doppler effect essentially means that when a wave is travelling away from an observer, the wavelength of the wave increases. So the best way to understand the Doppler effect is to consider sound waves, and then we're going to consider then how that relates to light. So we have a sound moving towards an observer. So let's say we've got an ambulance. So we've got an ambulance here, and it's got a siren. So let's firstly consider what happens when we have the ambulance going towards a stationary observer. Because of course the sound from the siren is going in all directions, and it's also going towards this observer here. The observer's not moving, the ambulance is going in this direction. So what tends to happen is the wavelengths, or the waves, bunch up because the sound source is moving along with those waves, so they tend to bunch up. Whereas going away from an observer, because the waves, or the sound source is moving, the waves tend to stretch out. So we look at this in terms of wavelength, the distance between two waves. When the sound is moving towards an observer, the wavelength decreases. And moving away from an observer, the wavelength increases. Okay, now there's a relationship between frequency and wavelength. So the speed of the wave is equal to the wavelength times the frequency. So in other words, what we can say is that the frequency and the wavelength are inversely proportional. As the wavelength increases, the frequency decreases. So when the wave is moving towards an observer, we've got a low wavelength and a high frequency. And when it's moving away from an observer, we've got a high wavelength and a low frequency. Now the frequency is the pitch of the sound. So as the ambulance is moving towards the observer, it's got a high frequency, a high pitched sound. The siren sounds high pitched. Moving away from the observer, it's got a high frequency, a low pitch, so therefore it's a low frequency, low pitched sound. So how does this relate to light? Of course you'll recall that light is part of the electromagnetic spectrum. I'm just looking at visible light here, but it certainly, this process relates to all parts of the electromagnetic spectrum. So in order, the visible light is red, orange, yellow, green, blue, indigo and violet. And if we're to continue on through the spectrum, we've got ultraviolet, then we've got X-ray and gamma ray. And down this way we've got infrared, microwave and radio waves. Alright, so let's have a look at the frequency and wavelength. Remember, with the electromagnetic spectrum, what changes? The speed of the wave is the same all the way through the spectrum. What changes is the frequency and the wavelength. And the red part of the spectrum has a longer wavelength and a lower frequency. The violet side has a shorter wavelength and a higher frequency. Edwin Hubble identified that the light coming from distant galaxies was red shifted. So that meant that the light had shifted towards this end of the spectrum, shifted in that direction. So what that means is that the wavelength of the light coming from those distant galaxies had a longer wavelength. Now if we go down to the Doppler effect, a longer wavelength means that the light source is moving away from the observer. So what Edwin Hubble was able to say is that red shift means that the light from those distant galaxies is moving away. Moving away from the observer. So what that means is that Hubble said that that means that this is evidence that the universe is expanding. So Hubble's discovery was that light from the distant galaxies was red-shifted. Red-shifted means that the light has a longer wavelength. It's moved towards the red part of the spectrum. And that means that the light source is moving away from the observer. And that means that the universe, or it supports the idea that the universe is expanding.